Sometimes you're going to have expressions with variables on both sides of the equation, and one of the things you have to do is collect all of the expressions that have variables on one side of the equation or the other. So let's start with the first example. 2x plus 5 equals x plus 8. What you can do here is all of the things we've done before, and you have a certain amount of flexibility in terms of the side of the equation on which you want to collect things, and whether you collect the variables first or other stuff. I would suggest collect the variables first, and I always like to collect the variables on the side of the equation that's going to give me a positive coefficient. So in this case, if I subtract x from both sides, on the left side I'll have 2x minus x plus 5, and on the right side I'll have x minus x plus 8. So I'll put in the minus x this time, but you don't want to do that normally because you're going to be sort of wasting time. After you've practiced it a bit, you would go immediately to this line where you have simply x plus 5 equals 8. Alright, so you've collected all of the x terms on the left-hand side. Now, of course, you want to get everything else on the right-hand side, which means subtracting 5 from both sides. This time I won't write that in. If I subtract 5 from the left, it disappears. If I subtract 5 from the right, I get 3. And of course, as always, you can check your answer by plugging in 3. On the left-hand side, you have 2 times 3 plus 5. That's 6 plus 5, or 11. On the right-hand side, you have 3 plus 8, which is 11. So it's a true statement. So let's try it again for this one. Notice we've got 4x on the left and 7x on the right. If I collect on the left, I'll be subtracting 7x from both sides, and I'll end up with negative 3x on the left. Now, there's nothing wrong with that, and we've seen equations before that have negative coefficients. However, I've noticed that I make more mistakes, and I've seen students make more mistakes whenever there's a negative coefficient. So if you can avoid dealing with a negative coefficient, it's far better. You're far less likely to make a mistake. So here, I would subtract 4x from both sides. If I subtract 4x from the left, it disappears. If I subtract 4x from the right, I end up with just 3x. And now I have the variable expression isolated on the right. I can add 4 to both sides and get negative 3 equals 3x. And for whatever reason, this is the stage where students make the mistakes. If you divide by that positive coefficient, you're just less likely to make the mistake than if you divide by a negative coefficient. If I divide by positive 3, I end up with x on its own on the right, and I end up with negative 1. I think the mistake comes because when you divide by a negative, you've got to change the sign. So even though we end up with a solution that is negative 1 in this case, we didn't have to change the sign. We went from negative 3 to negative 1, and that's just a little bit easier. You're less likely to make a mistake. So let's take a look at the last one here. You can't tell right away which side necessarily you want to collect the x's on, and there's also a little bit more going on here too because of that minus 10 at the end. So my suggestion here is just expand those products and then take a look at the equation you've got. So remember, using the distributive law, so 2 has to be multiplied by the 3x and the minus 5. Same thing on the right, the 4 gets multiplied by the 5x and the 2. So we have here 6x minus 10 and 20x plus 8 minus 10. The left-hand side, we can just leave it. The right-hand side, I would collect those 8 minus 10 and end up with 20x minus 2. Okay, so we've got 6x on the left, 20x on the right. It certainly makes sense to collect the x's on the right-hand side. So I'll subtract 6x from both sides. That gives me 14x there. I'll then add 2 to both sides. And those steps, with practice, you can do all in one go. You can collect the x's on the right-hand side and everything else on the left-hand side and go immediately from that line down to here, again with some practice, but I wanted to make sure you understood every single step. The last thing here is to divide by the coefficient, positive 14, and we end up with x on its own and negative 8 over 14, which should be reduced, right? There's a common factor of 2 in the numerator and the denominator. We can take out that common factor of 2 and end up with negative 4 over 7. Little trickier to test that or to check it, but you certainly can. I wouldn't advise doing it necessarily on a test because it'll take too long.